This video is going to be an introduction to matrix inversion. Some square matrices have an inverse matrix, which is a matrix that can be multiplied by the square matrix, and the result is an identity matrix. For a real number A, the inverse is indicated like this, a to the negative 1 power, which is equal to 1 over a. And the product of a number and its inverse is equal to 1. We can see that a times its inverse, the a's will cancel, and it will be equal to 1. Since we cannot divide by a matrix, we indicate the inverse matrix of A like this. And we show that the inverse of A, or a to the negative 1 power, is the inverse of A by showing that the following equations are true. We have A times its inverse equals the identity matrix. Or you can also say that the inverse of A times matrix A is equal to the identity. Note that the matrix of A to the negative 1 power, just the inverse of A, is also the matrix I, and also the matrix I are both square matrices that have the same dimensions as A. So A could be, for example, a 3 by 3 matrix, and this would also be a 3 by 3, and the identity would be a 3 by 3 identity matrix. If the inverse matrix exists, then it is unique and can be pre-multiplied or post-multiplied by A to get the identity matrix, as we see here. The inverse of a matrix will exist when the determinant of the matrix is not equal to 0. So, if you get a determinant of a matrix that is equal to 0, then there is no inverse matrix. However, if it's not equal to 0, there is an inverse matrix. Matrices that have an inverse are called non-singular, or invertible matrices. So they have an inverse. Matrices that do not have an inverse are just called singular. No inverse. Inverse matrices are particularly useful when we want to solve a matrix equation that has the product of a square matrix and the matrix we want to solve for on the same side of the equation. So for example, if we want to solve for the vector x in the following equation, matrix A times x equals b, we can use algebra to solve for this vector matrix x. But remember, we cannot divide by a matrix. So, since we can't divide each side by matrix A, we can multiply each side by the inverse of A to eliminate A from the left side. So we can do it like this. This will probably bring you back to your algebra days in middle or high school. So we got the inverse of A times AX equals inverse of A times B. So we just did inverse of A on each side. We know from up here that this is equal to the identity times x, and the identity times anything will just be that thing. So x equals the inverse of A times matrix B. So we've just solved for A conceptually. There are different ways for inverting a square matrix, which we will demonstrate in the next few videos. So this is just, once again, an introduction of matrix inversion. Hope you had fun.